All right, let's talk about something that can totally change the game for your ASP.NET Core projects: dependency injection. We're going to see how this one core principle can take your code from a tangled mess and turn it into something clean, maintainable, a masterpiece. Let's dive in.
You've been there, right? You need to change one tiny thing in your application. Just a little tweak and boom, the whole thing breaks. It feels like you're wrestling with this giant knot of code where every single piece is connected to every other piece. It's so frustrating, and it just grinds development to a halt.
That feeling, that's what you get from code that, well, it just fights back. It resists every change you try to make. It's a nightmare to test, and maintaining it feels impossible. But listen, this doesn't mean you're a bad developer. Not at all. It's actually a classic sign of a very common architectural problem. So, the villain in our story is a thing called tight coupling. This is what happens when your classes are responsible for creating their own dependencies. So imagine a report generator class that inside its constructor just creates its own database connection. Well, now they're stuck together, glued. You want to change how the database connects? Guess what? You have to rip open the report generator to do it. It makes your whole code base incredibly brittle. But don't worry, because every good story needs a hero, right? And our hero is an elegant solution designed to fix this exact problem. It's a design pattern that's baked right into the heart of ASP.NET Core, and we call it Dependency Injection, or DI for short.
So what is it, really?
The idea is actually super simple. Instead of a class making its own tools, we just give it the tools it needs to do its job. Our report generator doesn't create a database connection anymore. We just hand one to it when it's created. That tiny shift in responsibility, it is a complete game changer. So why go through the trouble? Well, think back to that tangled mess. DI makes our code modular, so we can actually test components in isolation, with a fake database or something. It makes swapping things out a breeze. Want to switch from SQL to Postgres? No big deal. And all this configuration happens in one central place, helping us build software that's flexible, not fragile.
Okay, so that's the why. But how do we actually do this in ASP.NET Core?
Well, the real magic happens when we register our services. And the most important decision you're going to make is choosing a service's lifetime. This basically determines how long an object gets to live and when it gets created. And there are 3 of them you have to master. First up, we've got Transient. Just think of this one as the always fresh option. Every single time any part of your application asks for this service, the DI container says, "Yup, here you go," and creates a brand new one from scratch. So when would you want this? It's perfect for those small, lightweight services that don't need to remember anything between calls. A service that sends an email or formats a string. It doesn't need to hold on to any information, so creating a new one each time is cheap and clean.
And the implementation? It's incredibly simple. In your program.cs file, it's just this one line, add transient. You're basically telling the application, hey, every time some component asks for an iGuide service, just whip up a brand new guide service instance for it. That's it.
All right, let's move on to our second option, scoped. Now this one is the real workhorse of most web applications. With a scoped lifetime, one instance of a service is created for an entire HTTP request. So the first time it's needed during that request, it gets created. Every other time it's needed within that same request, you get the exact same instance back. This is absolutely essential for things like your database context or your repositories. I mean, think about it. You want to make sure all your database operations within a single user action, like them saving a form, all happen with the same context and in the same transaction. Scoped is what guarantees that consistency. And notice the code. It's nearly identical. We just swapped add transient for add scoped. But that one little word makes a world of difference. It fundamentally changes the behavior to make sure all the operations within a single request are stable and consistent. And finally, we have the Singleton. This is the one and only lifetime. When you register a service as a Singleton, one instance is created the very first time it's requested, and that exact same instance is then shared across every single request for every single user for as long as the application is running. Now, you use this one with caution, but it is incredibly powerful for the right scenarios. Think about services that hold global state, like an in-memory cache, or maybe things that are expensive to create, like a logging service or a configuration reader. You really only want to set those up one time. Finally, the registration looks just like you'd expect. With Add Singleton, you're telling the framework to create a single logging service instance, and then share that exact same object with every part of your application that needs it for as long as it runs.
Okay, wow. We've covered Transient, Scoped, and Singleton. That is a lot to keep in your head. So how do you keep it all straight and make sure you're making the right choice when you're actually writing code?
This table right here, this is your cheat sheet. For lightweight services that need to be new every time, you choose Transient. For anything that needs to stay consistent across a single web request, like your database context, you choose Scoped. And for that one single shared instance across the entire app, like for caching or logging, you choose Singleton.
So here's the bottom line, the crucial point. This is not just some academic exercise. Choosing the correct lifetime is one of the most important architectural decisions you'll make. Getting it right prevents those subtle, hard-to-find bugs, it optimizes your application's performance, and it's a giant leap towards writing truly professional, clean code. By mastering these 3 lifetimes, you're not just managing dependencies, you're building a foundation for applications that are robust, scalable, and honestly, a genuine pleasure to work on. So the only question left is, with this new clarity and power, what will you build next?